Imagine walking into an ancient South Indian temple garden and realizing you're standing inside a live, open-air Ayurvedic pharmacy, designed centuries before modern hospitals existed. The trees, creepers, water channels, even the way shade and sunlight fall were not just beautiful landscaping, but part of a deliberate health and ecology system built into sacred architecture. Most people today think temple gardens were just decorative backdrops for rituals or places to relax before and after worship. In reality, many historic temple complexes in India integrated systematic planting of medicinal species, water management, and microclimate engineering that directly supported health, healing, and community medicine. There's also a common misconception that anything associated with temples is purely mythological or symbolic. However, inscriptions, traditional manuals, and surviving plant layouts show that temple gardens often followed practical Ayurvedic logic, focusing on real pharmacological properties, not just stories or legends. From a scientific perspective, an Ayurvedic garden attached to a temple works on three main pillars: species selection, spatial layout, and microclimate control. Species were chosen for their documented medicinal actions: antipyretic, digestive, antimicrobial, or wound healing, and planted where they could be easily accessed, identified, and harvested without damaging the ecosystem. Architecturally, these gardens were placed to optimize airflow, filtered light, and humidity. Courtyard gardens, peripheral groves, and water-adjacent plots used orientation, walls, and colonnades to control temperature and moisture, stabilizing the environment for sensitive medicinal plants and improving comfort for people using the space. Microclimate control also matters scientifically. Shaded, humid niches reduce water loss from leaves and can preserve volatile compounds in aromatic and medicinal plants, while open-sun strips support species that require high light for optimal phytochemical production. In many temples, this created gradients, zones where different classes of plants could thrive, from shade-loving herbs to sun-demanding shrubs and trees. Epigraphic records and temple inscriptions in various regions reference gardens or groves maintained for preparation of medicines, food offerings, and ritual substances. These records often specify endowments of land, labor, and water rights for maintaining temple gardens, indicating that they were managed assets, not incidental greenery. Traditional architectural treatises, including texts on sacred architecture and environmental planning, outline ideal placements of gardens, groves, and water bodies around major structures. They connect plant types with directions, soil types, and water sources, showing an early form of site planning that integrates ecology, human use, and climatic adaptation. Hydraulic engineering around temples, tanks, stepwells, channels, and percolation systems also supported medicinal cultivation. Controlled water levels, slow percolation, and runoff capture created reliable irrigation for plants and helped manage local groundwater, turning temple precincts into micromanaged environmental systems. In a number of temple towns, historical descriptions show that physicians and vadhyas associated with temples relied on nearby groves and gardens as primary sources of raw plant material for formulations. This creates a closed loop: temple as social hub, garden as pharmacy, water systems as infrastructure, and inscriptions as administrative backbone. From a modern scientific standpoint, temple gardens resemble early integrated health campuses, built environments that blend spiritual, social, and preventive health functions in one spatial system. If one strips away ritual language and focuses only on function, these gardens look very much like functional medicinal plant collections attached to community centers or clinics. In contemporary terms, this is comparable to hospital herbariums, botanical garden pharmacology sections, and research plots used for studying medicinal plants. The difference is that temple gardens were not isolated research facilities. They were embedded in everyday life, accessible to communities, and supported by stable social and economic structures. Modern urban design can learn from this. Integrating curated medicinal and functional plantings into schools, hospitals, and public spaces, combined with water-sensitive design and climate control, can recreate some of the health and environmental benefits. Such layouts support biodiversity, teach plant literacy, and offer raw material for community herbal initiatives, while also improving thermal comfort, air quality, and stormwater management. Temple gardens, when viewed through a scientific and engineering lens, are not relics of blind faith. They are early examples of integrated environmental design and community health infrastructure. They demonstrate how architecture, ecology, water engineering, and pharmacology can coexist in one coherent system that serves both body and mind. If this way of looking at temple spaces as open-source health technology interests you, explore nearby historic sites, pay attention to their plant life, and start documenting what you see. Subscribe for more deep dives into the science and engineering hidden inside sacred structures. And share this video with someone who still thinks temple gardens were just pretty background scenery.